Hello everyone! Today we'll be talking about horizontal and vertical asymptotes and how to find them using calculus. Let's get right into it. Alright, so let's quickly review what horizontal asymptotes can look like in the first place. So we can either have a situation over here like we do with f of x on the left, where we move toward y equals 2, or this horizontal asymptote, as x gets bigger and bigger as it approaches infinity. Or we can have something like we do with g of x, where we kind of oscillate around a certain y value, and as we move toward one end of infinity, we kind of get closer and closer to that y value, kind of stabilize at that y value. So you might be thinking, what kind of tool can we use to actually find what these horizontal asymptotes are and prove that they should be what they are? Well, the answer to that is just to use limits with calculus. And as you can see from kind of how I described finding the horizontal asymptote, with f of x over here on the left, I kind of just said that as x approaches infinity. With g of x, it was as x approaches negative infinity. So you might be thinking, if we take the limit as x approaches infinity or negative infinity, that should get us our horizontal asymptotes. And as a matter of fact, you would be 100% correct with that. So let's do that. Let's take those limits. So down here, we can take the limit as x approaches infinity of f of x. So if we look at the graph of f of x, as we get closer and closer to infinity, well, we kind of go toward y equals 2. So the very simple answer to this limit should just be y equals 2, or just 2. And then for g of x, it was a limit as x approaches negative infinity. Well, let's take a look at that. As we approach negative infinity, we kind of stabilize around y equals negative 3. So that becomes our very simple answer to the limit. That should just equal negative 3. Alright, so this question is asking us to find the horizontal asymptotes of f of x whenever it's defined to be 6x cubed plus 7x plus 4, all that divided by the square root of 9x to the 6th plus 2x cubed minus 3. So if you recall from a few seconds ago, the way that we find horizontal asymptotes is just by taking the limit as x approaches positive infinity and x approaches negative infinity. So let's do that, and I'll actually start with the positive infinity case. So here, if you recall from the video about relative growth, whenever we're taking the limit as x approaches infinity or negative infinity, and we have a rational function like this, we can kind of ignore all the terms that don't have the highest degree. So in the numerator here, the 6x cubed has the highest degree, so we can ignore the 7x and we can ignore the 4. And in the denominator, the 9x to the 6 has the highest degree, so this 2x cubed we can ignore, and this negative 3 we can ignore. So all in all, our limit effectively becomes the limit as x approaches infinity of 6, and then we're going to have our x cubed, and that is going to be divided by the square root of, and actually before I write that, let's think about what happens with the square root of 9x to the 6th. Well, this 9 is just going to become a 3. And this x to the 6, well, x to the 6, that's an even power. And whenever we raise numbers to an even power, they're always going to be positive. And then when we take the square root, well, we can have that power, but we have to remember that it's always going to be positive. So we have to put an absolute value here. So that becomes what it should be. So we have a 3 times the absolute value of x, that x is going to be cubed. Great. So now we can kind of rewrite the 6 divided by 3 as just a 2 divided by 1. So that just becomes a 2 right there in the numerator. And then the infinity, well, infinity cubed divided by infinity cubed, well, that's not really anything special. So this all in all just becomes a final answer of 2. So that means that our horizontal asymptote, we have one at y equals 2. Now let's try the negative infinity case. Well, I've kind of already rewritten here the limit in kind of the form that we want to work with. So we can write the coefficients here as just a 2 and then a nothing. But now we have to take the negative into account. So if we cube a negative, we still end up with a negative. But if we cube a negative and then take the absolute value, well, we end up with a positive. So this is still going to have a magnitude of 2 that we saw before, but we're going to have a negative here in the numerator and a positive in the denominator. And as we know, when we divide a negative number by a positive number, we get a negative. So our final horizontal asymptote is at y equals negative 2. Now let's think about vertical asymptotes. So as you will probably already know, vertical asymptotes form whenever a function kind of boundlessly goes to either positive or negative infinity. So in this case here, we have that asymptote at x equals 2 because from the right side, it's kind of going to positive infinity unboundedly, and from the left side, it's going to negative infinity. So that's what forms the asymptote. And actually, the way that we find vertical asymptotes using calculus is just by seeing when the limit is equal to either positive or negative infinity. So let's do that with this particular graph here. So if we take the limit as x approaches 2 from the left side of h of x, well, we just looked at that. Whenever it approaches 2 from the left side, it goes on to negative infinity. So that answer should just be a negative infinity. And then if we approach 2 from the right side, well, if we look at the graph here, 2 from the right side, that just gets closer and closer to positive infinity. So this answer should just be a very simple positive infinity. So as you can see, in both these cases, it's equal to some kind of infinity. So that's what tells us that there's a vertical asymptote. And so what the rule really is if we have the limit as x approaches a, either from the right side or from the left side, or just the regular limit as x approaches a, and either one of these is equal to either a positive or a negative infinity, that's when we'll have a vertical asymptote at x equals a. Alright, so this question is asking us to find the vertical asymptotes of f of x whenever f of x is defined to be x divided by x minus 1. So whenever we have functions written algebraically like this, the way that we find the potential points where we can have a vertical asymptote is just by finding where we divide by 0. So whenever we have like a number divided by 0. And so the way that we do that here is just to set this denominator equal to 0. So when we set the denominator of x minus 1 equal to 0, well, we see that we have a very simple solution of x equals 1. So now we have to use the limit criteria that we looked at earlier to see if this x is equal to 1 is going to be a vertical asymptote. So let's try that out. So here I'm going to take the limit as x approaches 1 from the right side, but really based on the criteria that we saw before, you could do the limit as x approaches 1 from the left side or just the regular limit as x approaches 1. But I'll do it from the right side just because that's what I chose. So with this limit, we can just kind of directly plug in the 1 plus into the expression. So we'll end up with a 1 plus divided by 1 plus minus 1. So in the numerator here, this is just kind of a 1 plus it's by itself. Nothing's really happening to it. So it's safe for us to just treat it as a regular 1. So I'll kind of write that here. This is going to eventually just be a 1. And then the denominator, well, that we have to think about a little bit more. So if we have a 1 plus minus 1, well, 1 plus is a number that's really close to 1, but slightly bigger. So if you have a bigger number minus a smaller number, you end up with a positive number. But remember that this 1 plus is super close to 1. So this number is going to be essentially 0, but still a little bit positive. So that's why we'll have that 0 plus there. So now let's think about what this should be equal to. Well, if we have a regular number divided by a super tiny number that's still slightly positive, and it's like super tiny, well, we're going to really get close to infinity, and positive infinity in this case, because we have a positive number divided by a positive number. So this is just going to become a positive infinity. So now that we showed that this limit is equal to positive infinity, well, that fits the criteria that we had for having a vertical asymptote. So therefore, at x equals 1 right here, we do have a vertical asymptote. That just about wraps everything up. Thank you for watching and have a great day.